Okay, good morning. Today's session we discuss about falsification and defalsification, which has been continued last session. That is, we have seen about the fuzzy propositions and fuzzy quantifiers. So, what is falsification? What is falsification? So, falsification is a method of converting a crisp quantity into a fuzzy quantity. So, this is achieved by recognizing the various assumed crisp and deterministic quantities as completely non-deterministic. So, and also you can see here, falsifier converts the crisp input into a linguistic variable using the membership functions which is stored in the fuzzy knowledge base. So this is what I said. So you can see here we have an falsifier, the block diagram is also discussed in the various sessions. Falsifier, inference engine, defalsifier, fuzzy knowledge base. So the falsifier is where you're going to convert the crisp quantity into a fuzzy quantity, or you can say that to a linguistic variable using the membership functions. Okay, an inference engine has been used in between the defalsifier and falsifier. So fuzzy knowledge base. So fuzzy knowledge base here we are going to input whatever using an if and use rule, and finally output. So next we see about what is inference engine. So inference engine. So normally, like we and already the practical example of an voltmeter is taken, which produces a crisp data, but these data can generate an experimental error. That is, you can see the previous figure also, which shows an associated member function, like measuring the voltmeter, or like we are going to take any example of a voltmeter or any how we are going to probable the ranges of errors for a typical voltage reading. So now if you go for the inference engine, you can see here using an if then type fuzzy rules, which converts the fuzzy input to a fuzzy output. So this inference engine is very important, where it acts a very important role between the falsifier and defalsifier. You can see input as that is whether you can go for the crisp set or the fuzzy set, x complement or x bar, and that x bar is given. We can use various rules because we have used if then rule, no? Rule 1, rule 2, up to rule R you can go. And x bar is A1 and y is B1, x bar is A2 and y is B2. And you can see x bar is AR or y is BR. So all these output values are aggregator. All these values are aggregator, and which is given as defalsifier. So you can see here totally aggregator is all the it is all the values are aggregated using a fuzzy, and finally the crisp has been defined using a defalsifier using. So now what is a defalsifier? So defalsifier converts a fuzzy output of the inference engine to a crisp using a membership functions, which is analogous to the ones used by the falsifier. So whatever we have done in the falsifier, it has been reverted and it is done in the defalsifier. So finally, defalsifier will give you an output from the inference engine. So it is also an inverse process of the falsification, where the mapping is done to convert the fuzzy results into a crisp results. And also it maps from a space of the fuzzy control actions, which has been defined previously. So that is what we have said, no? That is output have been taken from the control actions, that is non-fuzzy control actions. So what is the necessity of this defalsification? Okay, so actually it is it is due to the control, that is crisp control actions, which can be implemented in the practical implementations, like to be in operate to the control. So defalsification of the inference engine to crisp using a membership functions, which has been used by the falsifier. So normally there are 5 commonly used methods. We go for COA, which is called a centroid of area. Next BOA, bisector of area. MOM, mean of maximum. SOM, smallest of maximum. LOM, largest of maximum. This is a comparison chart between falsification and defalsification, which give you a clear idea. So basically, falsification is precise data which is converted into an imprecise data. Defalsification is that is imprecise data has been converted into a precise data. So the methods which we have used is inference. You know what is inference that we have discussed in the last sessions. Rank ordering, angular fuzzy sets, neural network, and all those things. And for the defalsification, we go for the centroid method, weighted average method, center of sums, maximum membership principle, and those things. The example of falsification is you can take voltmeter, and likewise defalsification, you can take a stepper motor and D to A converter. So complexity, that is, when you go for the complexity, the falsification is quite simple, and for the defalsification, it is complicated.